Piaget stages of cognitive development. The first stage is sensory motor, which is ages 0 to 2, which is basically object performance, is when you use motor activity without the use of symbols. The second stage is pre-operational stage, ages 2 to 7, which is when you use egocentric thinking, when you begin to use language, memory, and imagination. The third stage is the concrete operational stage, is when intellectual development is demonstrated. And the last stage is formal operational stage, is when you can think about multiple variables in systematic ways and you can formulate hypotheses.
The aim of the project is to determine whether the subjects are able to tell that the knife is not actually bent in the water, to determine if age is a factor in people understanding inclusions, to determine whether the subjects can classify and solve the problem, and to determine if children are able to construct logical mathematical problems by using different objects. The independent variable is the age of the subjects, and the dependent variable is whether the children perform the test correctly or not. The subjects in the experiment were 3-year-old male child, 5-year-old female child, and 3 7-year-old, which were 2 male and 1 female. 5-year-old female child, 4 9-year-old children, which were 2 male and 2 female, 2 12-year-old female children, 17-year-old female, and 2 18-year-old females. Experiment 1. Put a knife in each beaker of colored water. Ask the subject to view the knife from the side of each glass. Then ask the subject, how does it appear?
Quiet.
Huh?
Quiet.
Quiet. What in this cup?
Straight. Because it's yellow and it's bright, and you can see through. Yellow.
Okay. Cups.
Yellow.
Okay. What happened to the knives when I put them in the water?
That one is bent, and that one is straight.
Did they change any?
They appear big and both.
Did the knives change when I put them in the water?
Yes.
What changed about them?
The color.
But in water, they're bent.
This one is like curvy, and this one is bigger.
This one is bent, but this one doesn't appear. Well, from the outside, it looks refracted, like bent, but wider, that one looks like thicker.
Experiment 2. Place all plastic beads in the container. Have the subject observe the beads in the container. Ask, do you agree that all the beads are plastic, 20 are brown, and 20 are white? Then proceed to ask if they believe there are more plastic beads than there are brown beads. The correct answer is that there are more plastic beads than brown beads. Children know inclusion around the age of 8 years old.
Are brown beads, or is there more plastic beads?
Plastic beads.
Or are there more plastic beads?
There are more brown beads.
Thank you. Or are there more plastic beads?
More plastic beads.
Are there more plastic beads or more brown beads?
More brown beads.
Plastic beads or more brown beads?
More brown beads.
Do you agree that all the beads are plastic?
Yes.
Okay, and there's 2 white beads and the rest are brown. So are there more beads or are there more brown beads?
More plastic.
Plastic beads, or are there going to be more brown beads?
Plastic. More brown beads.
Thank you.
More brown beads. Brown.
Are there more plastic beads or more brown beads?
Brown.
Are there more plastic beads or more brown beads?
They're more brown beads.
Beads or more brown beads?
More plastic. They're all plastic.
Experiment 3. Give the subjects the cutouts of the shape in different colors. Have the subject group the shapes by the same color. Then ask the subject to divide the color groups into subgroups by shapes. Concrete operational children can complete this, while pre-operational children usually cannot.
And can you divide the color groups into smaller groups by shape?
Okay.
Okay.
Okay, now can you separate them into subgroups by shape? Okay, good job.
Okay, now divide each color group into smaller groups.
Okay, and now divide.
Experiment 4. Place 20 pennies in front of the subject, then show them a card with the number 16 on it and ask them to read it aloud. Ask the subject to show you the number of pennies that number represents and to move the extra pennies aside. Circle the number 6 and ask the subject to count out the number of pennies that number represents in the number 16. Underline the number 1 and ask the subject to count out the number of pennies that the number 1 represents in the number 16. Most subjects will choose 6 pennies to represent the 6 in the ones place, but choose 1 penny to represent the 1 in the tens place in the number 16. If they choose 1 penny to represent the tens place, point out the remaining pennies, and most children will say something like, "Those are 9 more."
Represent 6. Count them out for me.
Okay. Count.
Count 6.
Okay. 1,
Slide them over.
9.
Okay. Can you underline the 1? Show me how many pennies represent the 1.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Okay, can you put the rest of the pennies stand for?
Ones.
Okay.
In the paper, right?
Mm-hmm.
Count out how many pennies represent the 6.
1, 2, 3.
So how many is that?
16. Yeah.
So that represents the 1.
Represent the 1. Okay.
Okay. The 6 is in the what place?
Ones.
And the 1 is in the...
Tens place.
Okay, now.
Can you show me how many pennies stand for the 1? What about the rest of the pennies?
That they're off to the side and they equal 9.
How many pennies represent that number?
Okay.
Can you count out how many pennies represent the 1 and the 16? So if the 6 was in the 1's place, it represented how many?
6.
And so the 1's in the 10's place, so it represents
10.
Can you count out how many pennies represent the 1? So
Data from experiment 1. The pre-operational stage, one subject explained how he saw a quiet and bubbly knife. Another subject said it looked straight. Another said that the knife looked big while the other one was medium. The last two subjects both said that there was a color to the knife. The concrete operational stage, one subject explains that one knife turns bigger and the other one turns smaller. Another subject says that one knife is bent and the other is straight. The third subject said that the knives do not change. The fourth subject says that they appear big in both cups. And the last subject says the color changes. In the formal operational stage, one subject says that the knives are straight, but in water they are bent. Another subject says one is curvy and the one is bigger. Another subject said that one looks bent, but the other one doesn't really look bent. The fourth subject said on the outside it looks refracted like it's bent. And the last subject said that one appears wider and another one appears to be thinner. Data from experiment 2. For the pre-operational stage, the two subjects that said there were more plastic beads were the ages of 3 and 7, and the subjects that answered there are more brown beads are 5 and 2 7-year-olds. For the concrete operational stage, the two subjects that said there were more plastic beads were ages both 9, and the subjects that answered there are more brown are 8 and 2 9-year-olds. For the formal operational stage, the two subjects that said there were more plastic beads were both 18, and the subjects that answered there are more brown beads are 2 12-year-olds and a 17-year-old. Not all children around 8-year-olds knew inclusion. The data shows that to be true because some subjects very young answered the question correctly, while older children did not answer correctly. Data for experiment 3. Every subject was able to group the cutouts by color. 53% of the subjects were then able to create subgroups by shapes properly. 47% of the subjects did not correctly create subgroups properly. Majority of the subjects that performed the second task wrong performed the task by creating new groups by shapes instead of leaving the groups by color and then creating subgroups by shapes. Data, experiment 4. In the pre-operational stage, only one subject counted 10 pennies to represent the 10th place, and 4 subjects counted 1 penny to represent the 10th place. Concrete operational stage, only one subject as well counted 10 pennies to represent the 10th place, and 4 subjects counted 1 penny to represent the 10th place. Formal operational stage, 0 subjects counted 10 pennies to represent the 10th place, and 5 subjects counted 1 penny to represent the 10th place. Every subject correctly counted out 6 pennies to represent the ones place in the number 16. Only 13%, which is 2 subjects, correctly counted 10 pennies to represent the 10th place, while 87% chose 1 penny to represent the 10th place. After asking what the leftover pennies represent, more than 50 of the subjects responded with "those are 9 more" or "those are extra." Some subjects added the 4 pennies left from the 20 pennies back after the explanation. The strengths were that it was a lab experiment, meaning it was controlled. There was high generalizability because there was a range of ages, races, and gender. The weaknesses were that there were demand characteristics such as the experimenters personally knowing the subjects, and at times the experimenters told the subjects what to do instead of asking them to complete the task. None of the ethical guidelines were broken. All of the subjects had consent to participate in the experiment. All subjects were debriefed even if they did not understand, and no subjects were hurt.